Testing, testing, 1, 2, 3. Test, 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 test. Test, 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 test. Good morning. Good morning, everyone. Is this the last time you'll see me? Well, you know, maybe not. But certainly this semester. You know, if you're, I'll be doing the YouTube lecture thing, the YouTube lecture circuit next semester as well. So, you know, if you ever feel the, if you ever feel you'd like to check in and see that I'm still alive, I'll probably still be posting YouTube videos. But, yeah. Mark says all I'm hearing is vacation. Vacation! Yes. Yeah, this is not even a proper class. This is a review session. So yeah, but it's crazy. It feels like September was just like, well, I was about to say something that adults usually say, like, oh, it feels like September was just yesterday. But I don't know. I feel the months, and I have felt the weeks this semester for sure. Doesn't feel like September was yesterday to me. Feels like it's been a bit of a long haul, to be honest with you. But it's true. It's crazy that things are going to be changing gear. Things are switching over. All we have to do is get through the exams, and man, we're going to have a couple of weeks, and then it'll be right back into the grind. But, you know, hopefully over the course of this semester, both you as the students and we as the professors have gotten better at doing this whole online course thing. So hopefully things aren't as, you know, hopefully we can avoid the type of problems that we had at the beginning of this semester. However, I would remind everybody that probably a number of the professors that you are going to have in your next semester weren't teaching a course in this semester. So look forward to that. Yeah. Wakes up at 8. 5 more minutes. Suddenly it's 9 a.m. Yeah, that was... Yep. I sympathize with that perspective. Yeah. Well, you know, they say time flies if you're having fun, right? Yeah. So, do you guys want to Do you guys want to do some review? We should do some review. Yeah, it doesn't help that, like, at my particular latitude, I know people are taking this from all over the place, but in Hamilton, it's like 5 o'clock and it's like the dead of night, which is hilarious if you're from a more equatorial clime. It's probably difficult to think that that's possible unless you've been somewhere north in the winter or somewhere south in the summer, which is actually southern winter relative to the northern hemisphere. Anyway, classes are starting at 11:30, and 1 hour later is 11:35. Yeah, that's an interesting one. I feel like the concept of time itself has become sort of dilated and overburdened in this time, like simultaneously overburdened and underburdened. People just don't have the same consideration of time as they do when they have to actually physically travel somewhere. But yeah. So generally speaking, this is going to be a student-directed review session, so I'll give you guys a few moments. If you have any subjects you'd like me to cover, please put those forward now, and yeah, we can get to it. Time also flies when you're stressed and in the middle of a timed exam. That is true. However, okay, this is going to be a weird recommendation, but if you're ever like in an exam hall and you have to use the washroom, use that energy. Hold it. Keep writing the exam, because you can write an exam twice as fast if you have to go to the bathroom. I got through a statics exam for only that reason. My handwriting was pretty sloppy towards the end of it, but I did okay on I did okay on it. So I've got a couple of requests. Can we go over how to use a SQL database in Python and flyles? Well, that's actually, those two are kind of similar things, in fact. So yeah, let's do it. Ooh, there's all kinds of red text on my screen. Oop. Oh my goodness. There. Documents, McMaster1MD3. Go to fall. Go to code. Make directory. Review. Go to the review directory. Get it? Oh, too many arguments. I CD'd twice. CD stands for change directory. Let's see here. Get it. Files. And data. Let's do database first. Database. .py. Bonus speed. Pee your pants and you'll write even faster. Yeah. But will the exam be twice as wrong? You'd be surprised how much sharpness it can bring to your brain to really have to go to the bathroom. Alternatively, bring a bottle and open. Oh no, oof, oof, my friend, oof. Yeah, actually, I found that that's also the case when I play video games. Is like, I'll be doing well in the video game. I'll take a break, go use the washroom, come back, and like I suck at the video game suddenly. But yeah, anyway. So enough tips and tricks. I'm not saying that you should chug 4 liters of water immediately before going into an exam session. I'm not saying that. But you know, might help. Anyway. So let's access some databases. So, the first thing that you want to do is you want to import the library for dealing with databases. Whenever you're doing any of this file working with files or working with databases, it is always recommended and uh, just about impossible. Well, it is legitimately impossible to do any SQL stuff without having imported the SQLite 3 library or something similar. With respect to other file operations, you can sort of get away with not using the CSV library if you're just working with CSV files, because all you really have to do is break it up by line and then split on commas. Sort of. And then, parse the individual bits. But, if you're working with anything like a JSON, as I'm sure all of you have figured out, you pretty much need the JSON library. But anyway, so the whole thing about SQLite is, in Python, we're kind of simulating the process of having a cursor, which is the way they are referring to the command prompt, that we, how I was using the command prompt to perform various SQL transactions in my terminal. Well, another way of talking about a command prompt is to call it a cursor. That's a much older way of thinking about it. Going back to the days of the Apple II and the Amiga and the what's the other one? Commodore 64. Much earlier than the Nintendo 64. So, fortunately for you, this is an open book test. So, if you need to take some time to look up some references about how to perform various actions, you have the ability to do so. You don't have to memorize all of this stuff. So, in order to access a database inside of Python, oh, I could just use the buttons, couldn't I? Boop, there we go. So, we wish to open up a database using the SQLite3.connect method. So, database is equal to SQLite3.connect, and then you just enter whatever the file name is. Let's just say example.db. And of course, whenever you're finished, we'll do some stuff. And then at the end, db.close. That will terminate everything, release control of the database, back to the operating system, and everything is cool. So, now that we have the database object instantiated, we can perform some operations on it. We'll need to open up the cursor in a separate line, though. So, cursor is equal to database.cursor. There we go. That instantiates a cursor object, which we can then use to actually send commands into the database, into the SQL system. So, cursor.execute. Cute. And then, you just give it a string, and this string is an SQL command. So any SQL command is valid here. So let's say we wanted to create table vgames. There we go. If we save that up, and I think that's correct. Python 3 database.py. Operation order. Near syntax. No? Do they automatically put the semicolons in? Maybe they automatically put the semicolons in. Incomplete input. Probably just I'm screwing up the command. Let me see here. That's dates. There we go. How do you create a table again? Boop. Oh yeah, you need to enter the schema, don't you? Right. Well, let's just make it easy. Loop. have a name, which is text, and a rating, which is an integer. There. Now can we execute? We can execute. No errors are produced. So if you take a look, you'll see that example.db has been created. We can then, if we want, we can populate the database as well. So, here's an interesting idea, though. Can we execute this twice? No, operation error, table vgames already exists. So, a neat little trick is you can actually try except to catch that error. So, if you try it and it doesn't work and you just pass if it doesn't, if you get an error there, then it will create the table if the table doesn't exist, but if it gets an error that the table already exists, it just leaves it, which is cool. So, cursor.execute insert into, let's see here, into vgames, Mario Bros, Super Mario Bros 3, and rating is, oh, and you need a, so because this is a string, if you're, if you want to insert the double quote character, you have to do one of two things. You have to use the escape character to access that, same way you do a new line, or you just have to use single quotes here. Let's just use single quotes. So Super Mario Bros. 3, and our rating is 100 because that is the best video game. There we go. Save that up. Execute. Syntax error. Have I made a syntax error? I must have. Insert into vgames. Values. I forgot a keyword. See, this is why it's good to be able to have the reference. There we go. So if we open up SQLite 3 over here and open example.db, there we go. Select star from vgames. Nothing. Oh yeah. So there's one other step here. In order to actually, like, there's a separate save step that you have to perform in order for the changes, the updates to the database to actually be affected. I believe it's commit. Yeah, cursor.commit. So if we do cursor.commit, there we go. That should save our values. Quit. There we go. No attribute. I think it might be db database.commit. I think that's an error in the slides that gets me every time. Yeah, okay. So it's database.commit, not cursor.commit. That's an error in the slides. It's kind of funny because technically the review session itself is an aid that you can use during the exam since it's open book and it's being recorded. That's kind of funny. So anyway, open example.db. There we go. Select star from table, or not table, vgames. And there it is. There is the data that has been inserted in Python. There you go. And so you can see how, so there's one other thing that you probably would want to learn how to do, and that is actually read stuff out of you would want to read information from a database as well as put stuff into a database. So let's go over that quickly. It's not that hard. So you just take your cursor and you execute some statement that will like give you output, right? So select star from vgames, for example. Then this, because this is something that returns output, you will get a return result from it. So if you capture that return result and store it to a variable, these things are actually iterable. So you can actually for loop over them, which is cool. We can also print rows and see what it looks like in raw format, and then we can print row as well. I think if we execute this, we're going to get 2 Super Mario Brothers 3s in the database, which is fine by me. Let's exit out of this so we don't have any conflicts. There we go. And bingo bango! Alright, I think we have just the one. Oh, okay. So it's, if you just print it, it's a SQLite3 cursor object. If you, again, yeah, if you print rows, there are 2 rows and they're the same. If we go back to our SQLite thing here, open example.db, and we select star from vgames. Always forget that. No table. Oh, that's because I did xmaple, not example. Close. Quit. Abort! So open example.db, select star from vgames, and there you can see this is the same database that is being printed when we print each of the rows in Python. So there you go. That's how to use databases using Python. I know I wasn't really checking a chat during that, but let's see how we are doing. Oh, yes. Mark has been picking up the slack. Boo. What are the libraries you will have access to when writing the test? All of them. Yeah, so all of the ones that we've been dealing with in lecture are installed on Jupyter Hub, so you don't have to worry about needing a library that's not installed. If you MSAFT test 2, does dropping of the denominator work from the course evaluations for that test? No! No, it does not. It's all Python questions on Jupyter, yep. Dates. We could maybe do dates, sure. We should do files first, though. Answers for the practice exam. Nope, sorry. No, none of those. Review recursion. Yeah. Is the exam similar to the assignments and tests? It's in the same format, for sure. It is... It's going to look pretty familiar. If you have been doing the assessments in this course so far, it's going to look very familiar, because it's being administered in the exact same manner. So select star, that's a good, select star means select all. So the star is the wildcard character, and that it just prints every column in the database. Recursion is being requested. So let me just oh no. How are we doing? Okay. Don't do this to me, stream. It's not fair. I have done everything I needed, like... Oh. Testing, testing. Testing, testing. Hello, hello. Well, that wasn't down for too long. Hello. Okay. So, in response to your question, Nicholas, your lowest assignment mark is going to be dropped, yes, and that is not, like, that is separate from the MSAF. If you MSAF, you get an exemption, and that's separate from the dropping of the lowest mark. Testing, testing, 1, 2, 3, testing, testing. I didn't mention SQL in the list above because we just did it. That's the list of things that I think I'm going to cover during this review session. So, covering things in no particular order, let's do two-dimensional lists, just for fun. So, it's going to be a useful thing for you guys to be able to deal with, it's going to be a useful thing for you guys to be able to deal with matrices. Hopefully all of you guys have done a little bit of linear algebra at some point. So, let's do another example. Get it, 2D list.py. So, let's do matrix multiplication. Let's write an algorithm for matrix multiplication. That's a reasonable thing. That's not on the test. This is an example that I just kind of plucked out of my brain, but I'm gonna do this so that I can watch to see if the stream goes down. So, matrix multiplication. If we remember, let's just look up a little bit of reference here. Google. matrix multiplication. So, for matrix multiplication, the thing that you want to do is you want to be calculating dot products, right? So this would be a good thing that I would say that's good. That's a good sub algorithm, right? Is calculating a dot product. But so let's start with implementing dot product over a couple of vectors, right? Vectors here means linear, or just single lists, not double lists, not nested lists. So def dot, it'll take vectors x and y, which should be of the same length. For I'm going to do it with a while loop just to be old-fashioned. So I is equal to 0 while I is less than the length of x. X, we'll keep the dot, or the output is, we'll set that to 0, and output plus equals x at I times y at I. There we go. And then we return the output, and there you go. That's the dot product. Very, very simple, right? All you do for the dot product is defined as each one of these values multiplied by each other. So 7 multiplies by 1, 9 multiplies by 2, 11 multiplies by 3, and then you sum them, as so. Very, very, very easy. Not difficult at all. So, now let's define matrix mult. We shall have two matrices, A and B. So, in order to multiply the matrices, we need to, in sequence, perform the dot product over. I always thought of the dot product like or the matrix multiplication as visual. Like you would take this column, the first column, and then you would multiply it down the matrix, and then you would record the values. So that's kind of the opposite of the way these guys are doing it. They're doing across this matrix first, but it doesn't really matter which order you do them in. But the thing that we want to do, first of all, is we want to be able to pick out the rows of A. So, we can actually define a further function in here to be able to pick out that's too complicated. So we know that the number of so let's first of all So the reason I'm pausing is I'm trying to decide which way I want to implement this, and I think I'd like to go I'd like the outer loop to be the rows of A. For each row in A, we will multiply each column in B, right? So for row in A, and then we want to multiply each column in B. The tricky part, though, is that columns. The tricky part is the way that columns and rows are done. Right? It's easy to get a row because you just use an index, but it's not as easy to get a column. So, for example, here's a matrix. Let's say matrix M is composed of 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. So this is how you represent a matrix inside of Python. It is a list of lists. It doesn't have to be a square one, though, in this example, so why don't we just, why don't we give it one more? 10, 11, 12. And we can, format it nicely. Maybe. Even though that's not technically a requirement. There we go. So, in order to access any particular row, all we have to do is, let's just close this off for the moment so we can execute this. If say we wanted to access the third row, remember this is 0 indexed, all we have to do is use a single index. Python 3 print. There. So you can see this picks out a row relatively easily. You just get it. However, to get a column, it's a little more tricky. To get a column, what you have to do is you have to actually grab it out of multiple rows. So column is equal to an empty list for row in M. Column is, you append to the column whatever is at the X index, whatever index you're looking for. So if we're looking for the second column, that would be index 1, right? So you just plop that in there, and then at the end we can print it. There we go. And you can see that that little procedure there yields 2, 5, 8, 11, which is the column of the matrix, right? Cool. I'm just going to check to see if you guys are following. Yes. Oh, thank you. Yeah, I haven't actually run the function yet, but thank you. Yeah, oh, it gets me every time. That gets me every time. Absolutely. So anyway, so let's go back here. So we've got our rows of A. What we want is to loop through each column in B. So let's use this sub-algorithm to extract our columns. So, so the number of columns in B is going to be the length of the first row, right? So, for I in range, length of B 0. So for I in the range of the length of the first row in B, which that gives us the number of columns, we are iterating over the column indexes, we can generate a column corresponding to it, right? Let's not call this row, though, and let's not call this M. We want that to be B, right? So call it B row. And we'll call this A row. There we go. We'll call this B column. And we want to pick out every ith element of each row. So there we go. So if we print that, yeah, so let's just print these things just to show that this is working. Save, save, save. Oh, yeah, I need to actually. Okay, so let's make another matrix, which we can test this on. N is... so the number of columns has to match the number of rows, because that's the rule for matrix multiplication. So let's do 6, 3, 2, 1, and 10, 6, 7, 2. There we go. Now, let's, get rid of this stuff, and call matrix mult on M and N. Yeah, so you can see we get the first row of A, we get the second row of A, third row, and fourth row. Ah, but you see, we have a bug. B is being constantly the second row. So, So let's see what I is doing. This is how you debug stuff, folks. You print it out, see if it matches what you want, and yeah. So, oh, wait. I'm printing B row, not B column. That'll do it. Let's see. Yeah, that's what we want. And that's the actual result that we're looking for, right? So yeah, it's like 6, 10, 6, 10, 3, 6, 2, 7, 3, 6, 2, 7, 1, 2, 1, 2. Yeah, so we are successfully extracting the columns. There we go. Just get rid of those guys. Well, actually, let's leave them in while we're doing this. So, now, what we want to do is we want to start producing our output. So, we will create an output list, and to this list we will append more lists. So, yeah, let's try that. Since it's 2D, hopefully that'll work. So, for each iteration here, we are producing a column, I think. Yeah, I may have done this the wrong way around, but that's okay. We can actually, you know what? Why don't we pre-initialize the size of output, and then we can just use indexing to add it rather than append operations. That seems like it might be more useful. Let me see what people are saying. Oh, yeah, the other thing you could do is you could take the transpose and then use the columns. Yep, you could do that, for sure. So, in matrix multiplication, we know that the size of the eventual matrix is going to be the number of rows multiplied by, the number of rows and the number of columns. Those are going to be the, things, right? So, yeah. So let's just calculate that. So, maybe I'm making it too difficult. Maybe I'm making it too complicated. Because we've already got the rows going on here, right? We've already got the columns going on here. So, let me just give me a second here. So, have I got this correct? I think I got these the wrong way around. It would have to be n multiplied by m in this case. Yeah, because you would take that and you'd take this column and apply it to this row. So I've got these reversed actually. Okay, that makes more sense. So we take this, we apply it, we take this and apply it there. That gives us the result. Let me see here. Boom, 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 boom. Yeah, so it would give us a column. So we're going to have to accumulate the columns rather than accumulating the other ones. So, so we should have the number of columns established. Yeah, okay. Okay, I know what I'm doing now, I think. So, if we have this, then what we want to do... Yeah, I think it would be easier. Oh man, it's so early in the morning. So the number of columns we're working with is, yeah, this guy right here. So for that, let's just initialize everything to 0. Out plus equals, we'll accumulate some sort of empty row for j in range length of A, empty row plus equals just a placeholder value, and then we'll add that, we'll append that onto out, and then if we print that, we should get a matrix of the correct size. If I remember to use my colons and unexpected indent. What line? Line 41. Oh, yeah, that's dumb. There. So, is that correct, though? Three? Is it 2 by 3? Is it going to be a 2 by 3? It's going to be 2 by 3. Yeah, it's a 2 by 3. Yeah, there we go. So now all we have to do is use the indexes. But that also means we have to keep the indexes. So, so rather than doing it this way, why don't we say for j in range length A, that converts it to indexes. So then the rows are A at j. This should give us the same gosh darned thing. Yep, it does. It's the same. So, now we just have to take our column, take the B column, take the A row, and perform dot product on them, and then put it into the matrix in the correct spot. So, out at ji, I think, is equal to dot of A at j with B call. Oop. List assignment out of range. Maybe it's the other way around then. We didn't get an array out of range problem, so maybe we have done it. None. Oh yeah, because you actually have to print the output. Or return the output. Return out. There we go. Okay, so this is the matrix that we get as a result. So let's just verify that this is correct. Result equals okay. So if we have 1, 4, 7, 10, right? 1 times 6 plus 4 times 3 plus 2 times 7 plus 1 times 10. So that's 6 plus 12 plus 14 plus 10, which is 8. Oh, I need to do this in columnar format. So that's 42. 42. There we go. How about the next one? This one as applied to this one. So that's 10 plus 24 plus 42, I think. 42, no, it's 49. Sorry. Plus 20. 2, 8, 10, 103. 103! And it has put it here. So I think that we may have the transpose of the matrix that we want, which is fine. You can either fix the algorithm here, or you could even perform the transpose operation, later on. It doesn't really matter. I was right. It is ji, not ij. So if we swap these two, I think that will fix it. Let's try it out. Invalid syntax. Yeah, that makes sense. This is probably also invalid syntax. Yeah. Yeah, that flips it. So our result is this guy, which is the transpose of the other one. There we go. So there you go. That's me working through an example of matrix multiplication. Yeah, I am doing n times m, not m times n, because if the matrices, the column and the row have to be, but yeah, anyway, Any update on the course eval statistics? Well, I'm so glad you asked. There is actually an update on the course eval statistics. We're currently sitting at 66.53%. If 9 more people fill out the course evaluation, we will hit the 70% mark, and today is the last day for them. So if you haven't done it, don't let the class down. Of course, I think if you're watching this, then you've already done it. So, there we go. I always find it's useful to have a little pad of paper with me when I'm programming, because I can make little doodles, and that can help me do the math. Anyway, so that is 2D arrays. Let's talk recursion quickly. I'm just going to keep going. I know this is like the hour, but I think I'm just going to keep going. So we've done 2D lists. Let's talk recursion. Get it? Recursion. Recurse.py. So, just to review, a recursive function is a function which calls itself. Classical examples are things like the Fibonacci sequence and the factorial, definition of the factorial. For this particular one, let's do the Collatz conjecture. So, definition, Collatz. So for those of you who, I think we've done the Collatz conjecture in this class, I think, right? How do you know if you've actually submitted course evaluations? I mean, if you click the submit button, I'm not sure. It's been a while. I haven't ever actually done the online one, personally. Back in my day, they were on paper. So, the Collatz conjecture is also a sort of classical thing. So the idea is if we start with any positive integer n, then if it's even, we divide it by 2, and if it's odd, we multiply it by 3 and add 1. So, and we keep doing that, and if we do that enough times, we'll eventually arrive at 1. That's the Collatz conjecture. So if we start with some value n, the base case for this recursion is, the base case is the one that stops the recursion, right? The base case, does not include another call to the function. So if n is equal to 1, then we don't have to do anything because we have reached 1. So return 1. Sure. Or return true. I guess we're testing the Collatz conjecture. If n, else if n modulo 2 is equal to 0, that is, if it's even, then we invoke a recursive call to Collatz on n integer divide by 2. You don't actually have to use integer divide since we know that it's divisible by 2, but you know. Else if n modulo 2 is 1, i.e. if it's odd, then we call the Collatz function on 3 times n plus 1. There we go. And let's, just so that this does something, we print n so that we get a sequence. Or, you know, let's be a little fancy. End is equal to comma. print collat's sequence for n equals n. Sure, let's set n up here. N is equal to, let's say, 8. Collat's n print finished. And let's see how that works. Python 3 recurse.py. Collat's sequence for n is equal to 8. 8, 4, 2, 1. So I picked one that is divisible by 2 all the way down because I picked a thing that's like base 2. So let's pick something that isn't, like 18. It goes 18, 9, 28, 14, 7, 22, 11, 34, 17, 52, 26, 13, 40, 20, 10, 5, 16, 8, 4, 2, 1. And there you go. That's the Collat's sequence for starting at n is equal to 18. So, yeah, but the operative idea here is that because the thing is calling itself, we can make the, we could do this using loops, right? Let's do that. Let's do the equivalent definition using loops. So, we can print that as well. We can say something like, while n is not equal to 1, if we print n using the comma thing, if n modulo 2 is equal to 0, then n is equal to n divided by 2. Else, if n modulo 2 is equal to 1, n is equal to n 3n plus 1. There we go. And that does, like, that's the same algorithm but expressed as a loop rather than as a recursion, right? So we can say loopy and recursive. Probably it'll go down. Yep. Testing, testing, 1, 2, 3, testing, testing. Okay, looks like we're good. So that's recursion. You guys, are there any questions that have popped up that Mark hasn't answered? Any questions for me? So, we've done that. We've done that. I suppose we could do some file I/O. Next? Yeah? Oh my god. Hold it together, please, Mr. Stream. So, let's do... Just for fun, could I run the Collatz conjecture on 27? Yeah, sure. Yeah, absolutely. 27. There you go. That blows up quite large before it comes back down again. They sometimes call the Collatz sequence the hailstone numbers because they have this tendency to, like, go up and down like hailstones in a thunderhead. Anyway, so let's get it some file io dot pi. So, all right. So in order to work with files, you're working essentially with what are called file handles, right? So in order to create a file handle, there's like there's an easy way and a hard way. The easy way is with open. Let's pick a file in this directory. Sure, recurse.py in read mode as file handle, and then this automatically closes the file handle when you're finished with it, so you don't have to worry about manually closing it like you do with a database. Forget the particular method names. My goodness. There we go. Yeah, fh.read. Okay. So if you perform a read operation, fh.read, you can store that as a string. Let's call it s. And then if you print s, you'll see what we get. Python 3 file io.py. There you go. You can see it just prints out the contents of that file. If you want to go line by line, it's read row. You can read individual rows as well, or maybe it's not that. Maybe it's read line. Yeah, read line. So the first line is empty, which is true. If we save that up, try her again, there we go. So that's, you know, it's not really much more complicated than that. You can also, you know, let's do something silly. So let's save S as fh.read. Let's, with open, recurse reversed .text as file handle. Remember, file handle is deallocated after this block ends, so you don't have to worry about reusing the name. File handle dot write. Oh, you want to open that in write mode. S -1 up into the last one before the last element, because I think that will remove the null character at the end, or the end of file character at the end of the file. Let's see if that works. Oh, let's not print it anymore as well. So so you can see that created a file called recurse reversed, and if we take a look at it, it's empty. Maybe I'm not writing it correctly. Well, let's chop off a little earlier then. Let's chop off the last 10 characters. Well, we're getting something. Maybe I'm just being fancier than I need to be. Yeah, there we go. Yeah, I was just being too fancy. So you can see that this is the previous. This is our previous file, and it's just been completely reversed top to bottom. So you know, you can perform some sort of manipulation on the file and then write it back, but you know, that's how file I/O works. Can I run one Python file inside of another? Generally not recommended, but yeah, I think you can. Can I post the Python files after class? Yeah, I could do that. Yeah. Yep. Oh, yeah. Yeah, so the mechanism, the agreed upon mechanism for using code from one Python file in another is to import that file rather than read it in as like a file I/O operation and then try to execute the code. But yeah. So that that's a little bit of file I/O. Recursion file I/O. Datetime. Okay. So I'm just going to do this in the interpreter, I think. You can import datetime or let's actually, from datetime import date and datetime and time delta. So datetime.now, you can see that is a datetime object corresponding to the current time. If you you can also x is equal to datetime year equals 2020 month, not month equals 12, day equals 12, let's say 25th, hour equals 6 a.m. And then minutes and seconds will be 0. There we go. If we have datetime.net, if we have the time of Christmas minus the time now, then you can see that it is 15 days till Christmas, or something. It's actually easier if you use the datetime parse or format. So string format time, strf time. The first, actually I'm using this incorrectly. Datetime dot strf time. The first argument is the time object that you want to format, and the second one is the format in which you'd like to print it. So let's say year, month, day, we could even say that year's, months, days, h hours, m minutes, and s seconds. And hopefully this works. Doesn't work on deltas, eh? Oh, let's see. Maybe there's a function for that. Python date time str f time delta. It's not printing as nicely as I want it to, but maybe that's because I'm not actually invoking print. Yeah, there we go. Yeah, if you use print, it looks nicer. So 15 days and this number of other pieces of time until Christmas. So there you go. That's some stuff on how to use datetime objects. Yeah. So that's 2D lists, datetime, recursion, and file I/O. And I think I got a request for something else. Floating point numbers. Yes. So once again, the thing about floating point numbers to keep in mind is that it's impossible to do equality with them usefully. If you are going to do, I'll do this in the interpreter again. If you want to do an equality comparison versus a floating point number, then you have to use a range, a small range around that number that encapsulates floating point error. So the thing about floating point is if you perform an operation like this, it'll print out like it's 0.2, but if you I think it's dot how does it go? Dot format. I forget how it goes. There's a way. There's a thing that you can do to make it reveal itself. Ooh, I closed the thing. All right. Python 3. How does it go? It's in the lecture notes though. Yeah, there it is. So, format 0.1 plus 0.1, something like that. Give it 60 decimal places of floating point number. So you can see that 0.1 plus 0.1 is not 0.2. It's 0.2 plus all of this garbage if you actually open it up under the hood. And interestingly, if you perform the same operation, 2.2, you get the same number. Well, I think it's mostly if you start doing division operations. Yeah. So, well, let's choose something that's rational, at least. Yeah, that works because it's in binary, right? 4/12, no. Man, 7? Sure, something like that. And so if you, the point is you have this very long sequence of things, and if you, the classic example is if you do something like this. You would expect that to be 6, right? So if you're performing an equality comparison between this guy and 0.6, I guess 0.6 is being silly about it as well. Well, at any rate, well, let's try. I can demonstrate this. Give me just a second. Yeah. So, if you have all of these guys, it's 10.1s, then you add them together, and you think that that's equal to 1. It's actually not. However, if the way you do it is you subtract one from the other, take the absolute value, and say this absolute value has to be less than some small number, then that comes out true, right? And you can even do that for a reasonably small margin. So this is the way that you should be doing equality comparisons on floating point numbers in all cases. Because of the floating point error, the floating point inaccuracy that comes from the fact that in floating point what you are doing is you are representing what it's true in floating point numbers that a finite decimal in the binary or in the decimal system, it may translate to a non-terminating sequence of binary digits, and if that's the case, it's going to be truncated at some point because a floating point can only store so much. And if that's the case, then exact equality comparison, that's never a thing that you want to try using floating point numbers. So yeah, that's I would say that's the important information to know about floating point numbers. Okay, thank you, Mark. Okay, I think we've gone, it's now 11 o'clock, and we started at 9:30, so I think that we'll call it here, unless anybody's got some emergency question that they have to ask me. Can I get a thumbs up? Well, thank you guys. I can't find the emoji. Yeah, it's been thanks guys. It's been a atypical semester. If we've made this one a good semester, then I hope you guys will have even much better semesters, you know, when classes are being held properly. But, yeah. Take her easy, folks. Good luck on the exam. Don't panic. Don't panic. Just take it one step at a time. In terms of general advice for the exam, when you are confronted with a programming problem, the number one most important thing that you can do is remember your basics. Just like in Kung Fu, remember your basics. Think about how the problem breaks apart into smaller problems. Solve those smaller problems one at a time, and then put those solutions together to make the big solution. So, yeah. Maybe we will see each other on campus, all of you guys. Well, it's been an honor to be your teacher. So, thank you. I'll do my best. See you in 2077. Yeah. Yeah. Cool. Well, yeah. Good luck, folks. This is your professor signing off for what might be the last stream of the semester. Take her easy. I feel like I should do something special. Like maybe grab a cat. I'm gonna grab a cat, and then we'll sign off with a cat. Wait, no, come on. Gotta get my headphones on. Oop. No, it's okay. It's okay. All of the people want to see you. There. Hello, Mr. Mars. There we go. This is Mars. He doesn't appear on the stream as much because, you know, he's a big boy. And he's usually sleeping anywhere. And he doesn't come to bug me when I'm on stream, but he also gives kisses. Yeah, you're a cutie. But there we go. There's... Let's see. Did we at least get some of that? Oh my god. Hello? There we go. Say hello again, Remy, because we had Remy and then... oh, this is the saddest thing in the world. Hello? Please work. Please work. Oh my gosh. I think Remy broke the internet, yeah. Oh, did you break the internet? Oh, there's a little bit. Yeah. It's terrible, because, like, I've done everything I can possibly think of to fix the internet, and it's... I think maybe we do have to change ISP. You know? Although, if we were to switch... If it's a mechanical problem, switching to Rogers isn't going to fix it.
Obviously, internet service provider?
Yeah. Unless we switch to Bell or something. Yeah. I don't know. Maybe that's a talk for Christmas. Over the Christmas break, maybe. Meow!